Hi students, welcome to Sankalp Learning Classes. In this session, we'll be dealing with 2 mark questions of chapter differential equation, and I hope you know the basic concepts and the concepts that you have studied in the chapter differential equation. Okay, so most of the concepts will be covered in this session, but since it is 2 mark questions, we won't be dealing with the questions that needed too much explanation or too much steps and all. It will be simple questions, but this is in the 2 mark session. I think they are touching every portion of this chapter. So most of the concepts will be covered here. And in the 1 mark session, they'll ask about the order of a differential equation, degree of an order differential equation. Sometimes they'll ask the sum of order and degree of differential equation. And then there'll be one question about homogeneous differential equation, that is about its degree of a homogeneous differential equation. Then these type of questions are asked for 1 mark in the 1 mark session, but in 2 mark session, most of the simple questions from each of the sessions are asked, except order and degree. That is not asked for 2 mark question. They'll be asking verification of differential equation. Verification means whether they'll be given a function, and they'll ask whether this is a solution of this particular differential equation. And then you have studied about variable separable form, so there will be some question from that section. Then you'll have some simple questions from a solution of a linear differential equation. Okay, so we'll straight away start the questions. Okay, so the first question of today this session is, show that. It may be asked show that or verify that. Okay, so here I'm writing show that y equal to a into cos x plus b into sin x is the solution of, which is the solution of d square y by dx square plus y equal to 0. So you are given a differential equation. What do you mean by this differential equation? It is an equation involving differentials, right? So y equal to a cos x plus b sin x, a function is given there. You have to check that or verify that whether that is a solution of the particular differential equation that they have given, that is d square y by dx square plus y equal to 0. So let us check. So given that y is equal to a into cos x plus b into sin x, right? What is y dash? What is y dash? Y dash means dy by dx, right? We are finding the derivative of the function y with respect to x, or we are finding out the first derivative, that is y dash or dy by dx, or all these are notations of the first derivative, right? So dy by dx is equal to, a is a constant. What is the derivative of cos x? It is minus sin x, right? A into minus sin x plus b into, b is a constant, and what is the derivative of sin x? Sin x is cos x, right? So this can be written as minus a sin x plus b cos x, minus a sin x plus b cos x. Now, what about y double dash? What about y double dash? That is d square y by dx square. You have to again find the derivative of this particular function, right? Minus a is a constant. What is the derivative of sin x? Derivative of sin x is cos x. So minus a cos x plus b is a constant. What is the derivative of cos x? It is minus into minus sin x into minus sin x. So this is equal to minus a cos x minus b sin x. So we have got y double dash. Why we found out y double dash? Because since in the differential equation it is d square y by dx square, right? So that's why we found out d square y by dx square. So that we have got, right? We have got. Now we can substitute this particular value in our equation. So this is our equation, right? Differential equation. So I'm going to substitute that value, minus a cos x minus b sin x minus b sin x plus y. What is our y? Y is a cos x a cos x plus b sin x. A cos x plus b sin x. Plus b sin x minus b sin x gets cancelled. Minus a cos x and plus a cos x gets cancelled. This is equal to 0. That is equal to RHS. So we started from LHS and we got RHS, which means it is y equal to a cos x plus b sin x satisfies that particular differential equation. If it satisfies that particular differential equation, we can say that it is the solution of that particular differential equation. Alright, so y equal to a cos x plus b sin x is a solution of the given differential equation. You have to conclude it like that, right? Now we are moving on to our second question. We'll do one more problem related to this, okay? That is the verification. Then the second question is xy equal to log y plus c. This is the solution that is given by them. And the differential equation is y dash is equal to y square by 1 minus xy, where xy is not equal to 1. So this is our differential equation. Okay. Here they have given a condition xy not equal to 1, because if xy equal to 1, you know, the denominator will become 1 minus 1 0, right? So that function will not be defined, right? So that's why they have given a condition. You don't bother about that. You are given a differential equation. This is a differential equation and you have to check whether this is a solution of this particular differential equation. So how will you do that? You have to find out the derivative, right? Here y dash is given, so you have to definitely find out the first derivative, right? So here I'm going to find out the derivative. So this is the product of two function. X into y is a product of two function, right? So we have to apply product rule. So x into first into derivative of second function is dy by dx, right? Plus y into derivative of first function is x, with respect to x it is 1, right? This is equal to, what is the derivative of log y? It is 1 by y, but it is variable y, but we are differentiating it with respect to, we are differentiating this with respect to x, right? So you have to multiply it with dy by dx, right? And c is a constant, so derivative is 0, right? So now I'm taking this x dy by dx, then I'm taking 1 by y dy by dx to the side. So this is equal to minus y. Now if you take dy by dx outside, this is equal to x minus 1 by y. That is equal to minus y. Okay, that is equal to minus y. So what is dy by dx? Dy by dx is equal to minus y by x minus 1 by y. So how will you solve it? Minus y by x into y is xy minus 1 by y. So that is minus y into y by xy minus 1. That is minus y square by xy minus 1. Minus y square by xy minus 1. But our y dash is y square by 1 minus xy. So we can make some arrangements here. Okay, that is, we have got minus y square by xy minus 1, right? Minus is there. So you multiply this minus here. Okay, take this minus inside to the denominator. Okay, so what will happen? That is, y square by minus of minus 1 will become plus 1. Minus xy is minus xy itself. Y square by 1 minus x square by xy. Y dash is equal to y square by 1 minus xy. So from this, what can you conclude? From this, what can you conclude? You can conclude that xy equal to log y plus c is a solution of the differential equation y dash is equal to y square by 1 minus xy. Alright. So we have done two problems related to verification. Now we are moving on to some questions from variable separable form. Okay. That is finding the solution of a differential equation. First order, first degree differential equation by using variable separable form. So I hope you know a differential equation is said to be variable separable form if it is of the form m dx plus n dy is equal to 0, right? M dx plus n dy is equal to 0. That is, we can explain it with the help of question itself, right? So first one is solve dy by dx is equal to 1 plus x square into 1 plus y square. Okay, 1 plus x square into 1 plus y square. So what is the order of this differential equation? Order is equal to highest power is 1, right? And the highest order, degree of highest order is also 1. So degree is also 1. Okay. Now, now we are going to, this thing is that variable separate means we are arranging x terms together and y terms together. That is, you can rewrite this one as dy by this 1 by 1 plus y square. I can take to this side, right? So 1 plus s square remains there and this dx can be taken to this side, right side, right? So you can write it like this: dy by 1 plus y square is equal to 1 plus x square into dx. Right now, what you have to do is that you have to integrate both the sides. Integrate both the sides. What is integral dy by 1 plus y square? Tan inverse y. Right? We have studied it in the integrals, right? Tan inverse y is equal to, what is the integral of this one? X is 1 is, integral of 1 is x plus integral of x square is x cube by 3 plus c. Integral of x square is x cube by 3 plus c. Tan inverse y equal to x plus x cube by 3 plus c. Okay. Now, so that is a solution. Now, we are moving on to second question. Not second question from the session variable separable form. All right. So I think this is our fourth question. So this is dy by dx is equal to 1 plus x square by 1 plus y square. Okay, so how will you do is you have to group x terms together and y terms together, right? So this is dy into uh, 1 plus y square into dy, right? This is equal to 1 plus x square into dx. Now what you have to do, you have to integrate both sides. Okay, so while integrating, what you will get? What you will get while integrating? This is equal to y plus y square integral is y cube by 3 is equal to this one. With respect to x, we are integrating, right? So it is x plus x cube by 3 plus c. Y plus y cube by 3 is equal to x plus x cube by 3 plus c. All right. Now moving on to our fifth question. This is an important question. Okay. Solve sec square x tan y dx plus sec square y tan x dy equal to 0. You have to solve this equation. How will you do it? Here I'm going to divide this one with, here you can see that in both the terms you can see that here tan y and here there is a tan x is there. So in order to cancel that one, I'm going to divide it with tan x tan y. I'm going to completely divide this with tan x tan y. Okay, so that is sec square x tan y dx divided by tan x tan y. Okay, plus sec square y tan x divided by tan x tan y into dy equal to 0. Okay, so here you can observe that tan y gets cancelled, right? And here is tan x and tan x gets cancelled. So this is equal to sec square x by tan x into dx plus sec square y by tan y into dy equal to 0. Okay, now what you have to do, you have to integrate this one. So this is equal to log mode tan x plus, isn't it? Derivative of tan x is uh, sec square x. So it is of the form f dash of x by f of x. So what is the integral? It is log mode f of x, right? So you have to know integration and differentiation in this chapter, right? Log tan x plus sec square y by tan y with respect to y. What is it? Again, it is of the form f dash of y by f of y into dy. So log mode f of y. What is f of y here? It is tan y. So it is log mode tan y is equal to 0, or it's actually plus c will be there, right? You can take that c to the right side and make it log c. Okay, since it's a constant, we can make it log c. Log c is also a constant, right? So we can give a name as log c. All right, so it is for applying a property. Okay, for applying the property of log. So that is log of, we have got log tan x plus log tan y equal to log c. The integration constant is considered as log c here. Okay. So this is equal to log of tan x into, we know tan x plus log tan b is equal to log of a into b, right? So this is equal to tan x into tan y is equal to log c. Now you consider power, you take e power x, okay, that is e power log tan x tan y equal to e power log c. So using the e power log x is equal to x, we can say, we can conclude that this one is tan x into tan y, isn't it? Tan x into tan y is equal to C. Tan x tan y equal to C. Alright. Now moving on to our next question. This is our sixth question, right? Solve e raised x into tan y dy plus 1 minus e power x into sec square y dy equal to 0. Here also, for cancellation, we are going to, here you can see tan y is there, and here there is a 1 minus e raised x. So here I am going to divide it with tan y into 1 minus e raised to x. I am going to divide the complete equation with tan y into 1 minus e raised x. So this one will become e raised x into tan y divided by tan y into 1 minus e raised x into dy plus 1 minus e raised x into sec square y divided by tan y into 1 minus e raised x dy equal to 0. Okay, so which all term gets cancelled here? So tan y and tan y. Here 1 minus e raised x and 1 minus e raised x. Isn't it? So what is remaining there? What is remaining there? That is e raised x by 1 minus e raised x dy plus sec square y. Isn't it? Sec square y divided by tan y into dy equal to 0. Now you know what will be the next step. Take the integrals on both sides. That is integral e raised x by 1 minus e raised x into dx plus integral sec square y by tan y dy is equal to 0. Okay. So here you can see that this is of the form f dash of x by f of x. Here you can see that if you take 1, f of x is equal to 1 minus e raised x. The derivative is minus e raised x, right? F dash of x is minus e raised x. Isn't it? F dash of x is minus e raised x. But there is a minus less here. So you have to multiply and divide with minus, right? So this is equal to minus log mod f of x plus, you know, the derivative of tan y is sec square y. So this is log mod tan y. Log mod tan y is equal to log c. The integration constant can be taken as c. So this is equal to log mod tan y minus log mod 1 minus e raised to x equal to log c. Log a minus log b equal to log a by b, right? So this is equal to log of tan y by 1 minus e raised to x is equal to log c. Okay, so if you take e power log, then this will be equal to tan y by 1 minus e raised to x is equal to c. So you can rewrite this one as tan y equal to c into 1 minus e raised to x. It is tan y equal to c into 1 minus e raised to x. Alright. Moving on to our seventh question. Now we can do some application level problems. Uh, Before application level, we can do a problem related to a particular equation also. Okay. So find particular solution of the differential equation dy by dx equal to y into tan x given that y equal to 1 when x equal to 0. Okay, so the differential equation is dy by dx is equal to y into tan x. You have to find out the particular equation when y equal to 1 and x equal to 0. Okay, so dy by dx equal to y tan x. So what you have to do, you have to first separate this into variable separable form, right? So this is dy by y equal to tan x into dx. Now you can take integral on both sides, right? If you take integral, this one will be log mod y equal to log mod sec x. The integral of tan x is log mod sec x, right? Plus c, you can write it as log c. Okay, so this is log y equal to log c into sec x, right? Log a plus log b can be written as log ab, right? It can be written as log ab. So this is log c into log sec x, right? Log c into sec x. So if you take e power, then you will get y equal to c into sec x. Y equal to c into sec x. This is a general solution of the given differential equation. Okay, this is the general solution, but you are asked to find out the particular solution when you have to find out the particular solution when y equal to 1 and x equal to 0. When y equal to 1 and x equal to 0. So y equal to 1, put y equal to 1 and x equal to 0 in that. So our general solution was y equal to c into sec x. So this is 1 equal to c into sec 0. What is sec 0? You think about cos 0. Cos 0 is 1. So what is sec 0? It is 1, right? So 1 equal to c into 1, which means c equal to 1. So what is particular solution? 1 into y equal to 1 into sec x, that is sec x. Y equal to sec x is the particular solution at y equal to 1 and x equal to 0. Alright. Now we are moving on to our next question. This is an important question. Okay, it's an application level problem. Find equation of the curve passing through the point minus 2 comma 3 given that slope of the tangent to the curve at any point x comma y is 2x by y square. It is 2x by y square. So what you have to do, you have to find out the equation of the curve that is passing through the point minus 2 comma 3, and they have given that the slope of the tangent to the curve, okay, slope of the tangent to the curve at any point is 2x by y square. And what is the slope of the tangent? What do you mean by slope of the tangent? It is nothing but dy by dx. This is slope of the tangent. This is given as slope of the tangent at xy. At any xy is given as 2x by y square. 2x by y square. You have to find the equation of the curve passing through the point minus 2, 3. Okay. So first you have to find the general solution, right? So for that I am using the variable separable method. That can be used here, right? So y square into dy equal to 2x into dx, right? Now what you have to do, you have to find out the integral on both sides. So integral y square dy equal to integral 2x dx, which means what is integral y square? It is y cube by 3 is equal to 2 into x square by 2 plus c. So that is y cube by 3 is equal to x square plus c. Okay. So what is y? Y equal to 3, and what is x? X equal to minus 2. So at that particular point we need to find out the equation, right? So this is 3 cube. 3 cube is 27 by 3 is equal to minus 2 the whole square is 4 plus c. So what is the value of c? 27 by 3 means it is 9, right? 9 equal to 4 plus c, which implies c is equal to 9 minus 4, that is equal to 5. C is equal to 5. C is equal to 5. So what is the general solution? Y cube by 3 plus equal to x square plus 5. Y cube by 3 is equal to x square plus 5 is the particular solution, or it is the equation of the curve passing through the point minus 2, 3. This is how you find out the equation of the curve. It is actually the particular solution of that differential equation. All right. So these type of questions are also important in 2-mark session. Now we'll discuss a few questions from solution of linear differential equation, that is finding the integrating factor and then finding the solution of differential equation. All right. So next question is dy by dx plus 3y equal to e raised to minus 2x. So here you can see that this is of the form dy by dx plus p into y equal to q, where p and q are either constants or functions of x. Here you can see that p is equal to 3 and q is equal to e raised to minus 2x. This is a function in x and this one is a constant, which means this is of the form dy by dx plus py equal to q. So how will you solve this? You have to first find out the integrating factor. How will you find the integrating factor? Integrating factor is equal to e raised to integral p dx. E raised to integral p dx, right? And then how will you find the solution? Y into integrating factor is equal to integral q into integrating factor into dx, right? This is how you solve this particular equation, differential equation, right? So here I'm going to use that method. First, we are going to find out the integrating factor. Integrating factor is here p is 3. So e raised to integral p dx will become e raised to integral 3 dx. Okay, so that is e raised to what is integral 3? Integral 3 is 3x, right? E raised to 3x. So y into integrating factor is equal to integral q into integrating factor into dx. So this is y into e raised to 3x is equal to integral. What is q? Q is e raised to minus 2x into e raised to 3x dx. E raised to 3x dx. Okay, so y into e raised to 3x equal to integral. What is e raised to minus 2x plus 3x? That is e raised to x, right? Integral e raised to x into dx. This is y into e raised to 3x is equal to what is integral e raised to x? It is e raised to x plus c, right? So this is the solution of the given differential equation. All right, this is how you find out the solution using integrating factor. Okay, we'll do 2 more problems from that section. So the second question is solve dy by dx plus y by x is equal to x square. So here it is of the form dy by dx equal to py equal to q. Okay, so here what is p? P is equal to 1 by x and what is q? Q is equal to x square. Both are functions in x, right? So first we need integrating factor. Integrating factor is e raised to integral p dx. This is e raised to integral. What is p? 1 by x dx. What is integral 1 by x? It is log x. E raised to log x. Right? So what is e raised to log x? It is nothing but x by property of log and exponential. Right? So this is y into integrating factor is x is equal to integral q is x square into integrating factor is x dx, right? So this is y into x is equal to integral x cube dx. Integral x cube dx. So what is integral x cube? It is x raised to 4 by 4 plus c. So what is the solution? Yx equal to x raised to 4 by 4 plus c. All right. Moving on to the last question of this session, it is solve x dy by dx plus 2y equal to x square. So if this satisfies the form dy by dx plus p into y equal to q? No, because here you can see that there is an extra x. So what you have to do, you have to eliminate that x. How will you eliminate that x? Divide throughout by x. So this will become dy by dx plus 2y by x equal to x square by x, right? So that is dy by dx plus 2 by x into y equal to x, right? So what is P? P is equal to 2 by x and Q is equal to x. P is equal to 2 by x. Now first you find out the integrating factor. E raised to integral P dx, right? So this is E raised to integral 2 by x dx. You can take this 2 outside. Integral 1 by x dx. What is integral 1 by x dx? It is log mod x. Log mod x. Right. So here you can apply the property. A log x equal to log x raised a. Right. So this can be written as E into log x power 2. E into log x power 2. This is equal to nothing but x square. Which is x square. So we have got the integrating factor. It is x square. Now y into x square is equal to integral. What was our q? What was our q? Q was x. X into x square dx. X into. So this is a formula that we are using here. Okay. Y into integrating factor is equal to integral q into integrating factor dx. Okay. So this is y into x square is equal to integral x cube dx. So what is integral x cube? It is x raised to 4 by 4 plus c, right? So this is y into x square is equal to x raised to 4 by 4 plus c. Okay, so these are some of the important questions that are asked in 2 mark session. You have to practice more problems related to each of the type that we have discussed here. I hope this session was useful to you all. Thank you.